Soft pneumatic actuators are ideal for interacting with fragile objects. However, challenges remain in modulating the stiffness and deformation of these actuators. In this work, a reconfigurable soft pneumatic actuator that exploits metamaterial reinforcements is proposed. The actuator's design allows users to rapidly interchange the meta reinforcements to achieve the desired stiffness or deformation. To this end, a large number of meta reinforcement combinations were explored, utilizing 3 different metamaterial topologies with diverse distributions and relative densities. Actuators with graded meta reinforcements were evaluated experimentally, demonstrating the ability to shift the deformation curvature based on the local stiffness of the reinforcements. Other nonlinear combinations of relative densities were explored, achieving non-bending deformations in the soft actuators. For instance, twist motion and hinge-like deformations were shown. Actuators with the different meta-reinforcements were simulated using finite element analysis to validate their mechanical responses. The motion of the actuators was also estimated with the kinematic model, which proved to be able to approximate their position. Foot handling was used as an application case, showing the capacity of the actuators to manipulate objects of different shapes and weights. Thank you for watching. You can find the full open access paper in the journal Materials and Design.